So here I have the hyperbolic sine function. Y is equal to sine h of x, or e to the x minus e to the negative x, all divided by 2. Okay. So that's part A. Part A says graph this function using graphing technology. I've used an application called Desmos to graph this. In part B, it says to predict the shape of its derivative, sketching your prediction. Okay, so let's take a look at this function here. Looks very much like the cubic function, right? So as an aside here, okay, the cubic function looks something like that. Okay. Now using this will allow us to develop a very good intuition of what the derivative of our hyperbolic sine function is going to be. Well, we know from the power rule that y prime for a cubic function will be a quadratic function, okay, or graphically a parabola. Okay, so if I were to sketch, let me do this in a different color. Okay, so take orange here. Y prime is equal to 3x squared. And if I were to graph my derivative of my cubic function, okay, the cubic function, because it's a parabola, looks something like this, right? That's better. Something like that. Okay, so I would expect no different from this curve here. Okay, so a good place to start would be probably at 0 here. Okay, I see that the slope here is something very close to 1, right? Okay, the slope of the tangent. Okay, it's going to be a positive slope. Okay, so you can bet that the derivative, okay, at that point will be 1. And as you move along to the right, what happens to the slope? They get steeper and steeper and steeper. And steeper slopes have higher values. Okay, so the derivative will do something like that. Okay, and as you go to the left of 0, what happens to the derivatives? They also get steeper and steeper and steeper, or they become greater positive values. Okay, so the derivative, if I were to sketch it on the same graph here, would do something like that, right? Just like our cubic function. Okay. So I've gone one step further and I have actually differentiated my hyperbolic sine function. Okay, we can differentiate this, right? That's simply an exponential function. And you're going to see the differentiation algebra in question number 18, I believe. Okay, and after differentiating it, I have grabbed its derivative, and our intuition was right. Okay, obviously, you know, this was a rough sketch, so it's still a little bit off in terms of the exact values. Okay, but the underlying idea is the fact that the derivative, okay, looks like a parabola, right? And that's evidenced here by this purple line.